develop some hybrid approaches in this section. And this is going to dovetail with some of what Matt will talk about on Thursday when he talks about surveys in the digital age. I'm just going to give you some templates, ways to think about creatively combining digital trace data with other types of more conventional tools in the social scientist toolkit, such as surveys or field experiments. So let's take a look. Let's start off. I want to organize the discussion around the set of strengths and weaknesses of digital trace data that we set out with, which draws from Matt's book. And we're going to talk about it in the context of apps. So as you may recall, we identified the following limitations of digital trace data: that it's incomplete, or all the data we want is sometimes not there for a variety of reasons. It's inaccessible. It's hidden behind paywalls or behind private data sets. It's not representative. We don't know who's tweeting about what, where. There's drifting, right? People moving across platforms, platforms changing. There's algorithmic confounding, properties of algorithms embedded in social media sites or search sites that make human behavior look like something it's not. It's dirty, it's unstructured, it's difficult to work with. And it's sensitive, right? That there's often cases where we're collecting quite a bit of data about people that would be, it could be harmful if it got out in the world. So I'm going to try to argue that we can't throw the baby out with the bathwater. These are serious limitations, but what are the alternatives? So survey response rates continue to drop, right? One of the last surveys I did had a 1% response rate. And that was from a pretty reputable polling firm. And this was a while ago. This was maybe like 5 or 6 years ago. One of the last conventional surveys, I'll say. And many of our most important questions require this type of data, right? Longitudinal data to look at change over time. Relational data to look at how social relationships are changing things. And also qualitative data, right? So many of our most important questions are about which ideas spread and why. Why do people think certain ways? Text is so obviously going to be an important part of the future of computational social science and probably social science more broadly. So are we really going to leave these data alone? I think not, and I think there's also some other advantages that digital trace data have that conventional sources do not. Again, that they're typically larger, that they're always on, that they're collecting data all the time, or most of the time, we hope, and that they're non-reactive, that we might avoid social desirability bias. So the question I would like us all to think about is, can we have our cake and eat it too? Is there a way that we can work with digital trace data, but maybe merge it with more conventional sources of data collection, like a survey? And I'm going to argue that apps, if we build our own apps, that's a really interesting way to try to think about getting around some of the problems and really making some of the good parts even better. So I'm going to argue that apps can help us address the incompleteness of data, the inaccessibility of data, the non-representativeness of data, the dirtiness of data, and the sensitive nature of data. So what do I mean by an app? In my own work, about 5 or 6 years ago, I had been doing a lot of work with Twitter data, a lot of work with Facebook data, collecting a lot of the fields we were just looking at, right? Like things like the number of times something was retweeted, what time of day it was tweeted at, the number of followers of the person who tweeted it. And I could build a model kind of like Duncan Watt's talk showed last night that could maybe predict some useful some useful theory of why information spreads. But then someone might ask me, okay, Chris, well, but how do you know those aren't the same 10 people in the same dorm room spreading that information back and forth to each other? Or how do you know that it wasn't only women who shared that? Or it wasn't only people in North Carolina, right? Or it wasn't that offline people were all doing one thing that then had some effect on their online behavior, right? And I couldn't answer any of those questions. And I got kind of bummed. I was like, maybe, and remember in our hype cycle that we've been showing throughout the day, right? This was the trough of despair. This was my trough of despair. Like here we had this great data. And a lot of my work is on the spread of ideas and culture, right? And so I was so excited about these data, and I had written pieces about the great value of these data. And yet I had this reckoning. I realized we needed to do something. So the solution I came up with was to build an app that would allow. I was studying nonprofit groups and trying to understand how their posts go viral in a number of ways. And my internet connection is being buggy here, and I can't spell. And I've apparently got a virus. Great. Okay, so here, the trifecta. Here's the app that I built many years ago. And essentially, here's the idea. So you are a nonprofit organization. I want to know everything about your posts and try to make better predictions of which ones are going to go viral. You, as a nonprofit organization, actually want to know the same thing, right? You're trying to call attention to your cause. You're trying to get people interested in what you're talking about, right? Wouldn't you like a complimentary audit of your social media outreach, right? So here's the deal I'll make with you. If you install my app, right, and agree to share your data with me, my app will deliver to you a report about how you might improve your social media outreach based upon a comparison of your data to that of your peers, all of the other people who have installed the app, right? And at the time, apps were a new thing, and many nonprofit groups really wanted to know what was working, right? Nobody knew, and I'm not really convinced anybody still knows, right? And so here's how it works. So the representative of the organization, we have a sampling frame. We send them an email that says, there's this tool you can use to optimize your outreach, right? They click here. They're then redirected. It no longer works, so if you're there, our cloud server is down. We've deprecated the whole program based on an API change, actually, and the study concluded long ago. But anyways, if you click there, you're then redirected to, or you were once redirected to an authentication dialog. And there, the user is saying exactly what type of data they're sharing. And there's a privacy policy linked, which includes an informed consent dialog and allows the researcher to specify very clearly exactly what type of data is being collected and exactly for what purpose and exactly how the data will be stored and all of the other wonderful principles of informed consent that we all should follow, right? And have to follow if your research is reviewed by an IRB. But even if it isn't, right, as our discussion of ethics hinted at yesterday, we need to be attuned to these things and need to hold ourselves to a standard that's higher than IRB, right? So in other words, the app is a contract with people, right? We are proactively asking them. We're being very forthright about what we're doing. And then as soon as we get authentication, right, then the app can make API calls to start collecting data of interest. In this case, I was gathering both the data that are public, so things like the text of the post and the number of times it was liked or retweeted, but also non-public data that is available to the owner of the page that they chose to share with me. So these are metrics like the number of women aged 15 to 35 who clicked on a link on January 27th, right? Or the number of people in North Carolina who clicked on a link. Or the number of people who moused over a link but didn't click on it, right? Some pretty rich data, about 100 additional metrics that I couldn't get without forming an individual contract with the user, right? Then, on top of that, we survey them. So after you go through the authentication dialog, you're redirected to a brief survey, and then you're asked, the representative of the organization is asked a series of questions that we can't measure from all those data. Things like, what is the annual budget of your organization? What do you do offline to call attention to your cause? What are the other, all these confounding factors that I was discussing earlier that I wasn't able to answer with the digital trace data alone. And once they finish the survey, they then get a report back with a series of visuals like this that tell them where their audience is coming from, how the size of their audience compares to other organizations in their field, what types of demographics they're doing well in and what they're not doing well in, and so on and so forth. Yeah, Jeff. Mm-hmm.
How do you bootstrap an application like that, right? Like the first few organizations
Yeah. Yeah, so we worked with a set of partner organizations to calibrate it up front. Yeah, so we had an initial sample. And by the way, like, I'm glad you brought that up because one of the other nice kind of byproducts of building apps is it, you know, and not all apps need to do some good in the world, right? Like that need to help nonprofit groups. You could also pay people to use apps, you know. But something like this ties social science to real problems in the world. And so there actually was a surprising amount of interest among the nonprofit groups we worked with to figure this out because they were all kind of scrambling, especially back in 2010, 2011 when this was going in the field, when everybody was really trying to figure out what makes something go viral, right? Yeah, good question. So we've got the public data, we've got the private Facebook data, and then we've got supplemental survey data. And I should say, and I want to be very clear about this, the private Facebook data that we collect was all aggregate data about audiences. So it wasn't the name of the person who clicked on a link. It was that a count of a number of people from a certain demographic who clicked on a link. Even though, in theory, you could get that name if you wanted to make that contract with the user, but that's obviously much more controversial. And if we look at the case of Cambridge Analytica, which is in the field the year after my study was in the field, you know, that study did not have as clear informed consent, I would argue, in part because we talked about international differences in institutional review boards. Because the study was led at Cambridge, it had much more, I think, modest or imperfect review, right? Shall we say, right? Which of course led to this huge, you know, issue, which actually Facebook responded to by changing its API. It was called Graph 2.0 to Graph 3.0. A major change was you weren't able to get information about friends of friends, and that was actually in response to the Cambridge Analytica breach and other similar apps that had violated that. So thinking through this at a time when, you know, you'd call the IRB about this and they'd say, nobody's ever built an app for social science research support. Now it's all over the place. You know, we have many examples of this, but so we're still working through these issues. But I think, you know, provided that we are careful about our public release of data, which is something we should talk about. We don't have on the curriculum, but hopefully all of you will discuss over lunches, and all of you on the live stream might discuss as well. You know, it's really a vitally important issue. Okay, so we've got public data, private social media data, and we've got survey data. And we can start to look at, you know, we can start to look at things with a much more careful lens, right? We eventually came to call this a social media survey app. And so these could probably be a class of web or mobile-based tools built by a researcher in order to collect some public or private data produced by social media users from an API, likely. Collect some type of supplemental information from them, such as demographics, using more conventional survey methods. And offer some type of incentive back to the user, something like an analysis or a financial incentive, right, to inspire them to, or to encourage them and to share their data. Again, using clear language that describes how the data is going to be used. And that was one of the issues with the Cambridge Analytica app, right? It just asked you, what's your personality? And it seemed like an innocuous thing that wasn't going to not only take your data, but your friends' data, right? So provided that we are clearly announcing ourselves as researchers. And that's a limitation, right? If you're interested in doing, for example, field experiments, this might compromise some of the science, right, if people knew that you were researchers. And we'll talk a little bit more about that when we talk about bots in just a second. So here's a paper linked here that discusses the various advantages of this hybrid strategy. Here is, from the paper, some ideas. We used to call it big data back then. You know, the steps that go into an app analysis. You authenticate with the user. There's some type of big data extraction. There's some type of supplemental data collection, maybe in a survey. There's some type of app analysis, and there's some type of app report that then gets delivered back to the user. So here's an example of how the Vir algorithm worked. It not only collected Facebook data and survey data, it also added data from Google to look at the effect of the broader environment of events. So for example, we were studying groups working on autism spectrum disorders or organ donation, and we discovered that we needed to know what was public interest in autism on a given day, because that was something that was going to be a confounding factor in terms of whether a message might spread, right? If there was a public controversy about autism spectrum disorders, we wanted to measure of that. So we collected Google Trends data, Google News data, Google Blogs data, and meshed all that up in a cloud server, then returned that to our app and delivered it to the user. So we were nervous when we did this first. We thought that even back, now today things are even more complicated in terms of whether people are willing to share their data. But back then, this was one of, or maybe one of the first studies in social science to use an app. We thought people would be scared of sharing their data. We got a response rate of about 40% of groups, which is pretty good, at least according to meta-analyses of organizational populations, which typically have higher response rates. We did reach out to them by phone, though, and I think that had a big effect, and on university letterhead. So that was a much higher cost recruitment. We saw minimal evidence of selection. So we didn't see that groups were, for example, installing the app if they were poorer, because maybe they had less resources to hire a social media consultant. We didn't see younger or more recently founded organizations more likely to use the app, because maybe they were more interested in social media in general. And we didn't see differences in the number of people who are using the app. So that was encouraging. But importantly, we could look at these data points to some degree, right? And we could look at the representativeness of our sample using all these demographic variables that we collect. And we can also use post-estimation weighting. We can start to try to assign a weight or an increased influence in a model to a person who's from an underrepresented category. And the important thing here is that we know what groups are underrepresented because we collect that supplemental data. And so here's a series of papers that describe in excruciating detail more about the payoff of apps and how they can be used for social science research. Questions so far? Anything from the live stream? Has anybody here built an app? Okay. Well, if you had built an app, you discover historically there have been some challenges. One is, at least a long time ago, when I was doing this, you needed significant coding skills. You needed to know HTML. You needed to know CSS. You needed to know something about cloud computing. You needed to know something about reactive programming. All those things, because of new tools that I'm about to show you, are now no longer necessary, or are necessary in a much, much easier to use format. But there's still another limitation, which is that there's a competitive environment for attention, right? Everybody's got an app now, right? So how are you going to get your app to get attention? Apps are no longer new. Now we have even more concerns about data sharing and privacy. That's another limitation. And compelling incentives, if your app is going to develop an incentive to offer an incentive to a user, those are hard to identify. Though again, we've done some new work looking at offering financial incentives to get people to share their social media data that again, with fully informed consent and disclosure about precisely what type of data would be collected. And we've discovered large numbers of people are willing to share their social media data for financial compensation. So that is another vehicle. And indeed, one of the ideas on the table, moving forward, we were talking about earlier about how many of us are working to try to promote access to industry data. One of the models that's floating out there is to allow someone who runs a survey to have some type of restricted access API that would allow you to then request pre-specified tables from the API that could be merged with your survey. So for example, if you were doing a study where you needed to know about how much exercise someone is getting, you could imagine making a call to a Google server with Maps data to ask the number of steps someone took in a day, right? You don't want to know that they went to Starbucks at 4 p.m., but you want to know the number of steps that they took. All that analysis could happen on a Google server, could be delivered back to the survey firm, and then merged with your survey, and you could get a really nice, clean measure of something, right? That's one of the ideas on the table, but again, it's a logistical nightmare of multi-factor encryption and many other engineering challenges. Okay. So, okay, so how would you build an app? And again, we're not going to go through every step. We don't have time. But I want to show you some new tools that have really reduced the startup costs, especially in R. And there's equivalent programs in other languages. But one that's really nice, and many of you have probably already used, is called Shiny. Shiny is a tool to create interactive apps natively within RStudio. So if you are in RStudio and you go to File, New, and then Shiny App, a toy example will open up. It's going to be a visualization of a histogram that you can mouse over and interact with, and it's just kind of a very simple, clunky app. Here's an example of another one, if it will load here. Let's see. Sorry, I'm having some internet connection issues here. Let's try to find one quickly. This is always dangerous. Here we go. Here we've got an example of a Shiny app. We are mousing over, looking at here health expenditure versus life expectancy. This is not really an app in the sense that we're just talking about. It's really just a tool for a user to interact with data. And here we're seeing the code that actually goes into building this app. And I'll talk about what each of these different parts of the code here mean in just a minute. But what's really neat is once the app is made, RStudio has a publish button that allows you to then put the app up on the internet, and then allows you to also host it at pretty high volume. If you expect it to have a lot of users, you can pay a little more to host on a higher volume server. So it really does allow you to avoid all the steps of registering with a cloud computing account, handling the CSS and the HTML to make it look in the way you want, and all of those challenges that I mentioned earlier. Now the trick is, of course, this is just a simple interactive visualization. If you wanted to embed a survey and store that data with safe, with very secure passwords, perhaps, you could imagine doing something like that with a few of the tools we've been working with, right? So you could imagine using the RTweet package to authenticate, right? And make calls for a user's tweets, and then administer a survey within a Shiny app by creating objects within the Shiny app, as I'll soon describe how to do, that say, what is your age, what is your gender, and so on and so forth, and then add additional sets in that script to say, send that data to a server somewhere where I'm going to store my data, all right? So there's three components of a Shiny app. There's one, historically, these were separate scripts that then had to be compiled. Now they all come together in one script where you define these three things. One's called the global part of the script. That's where you define variables that you might want to work with in both the user interface, what the user is seeing on their screen, and then also what types of analysis that the app itself is doing. If it's producing a visualization, what data is it loading and how is it analyzing it? What type of visualization is it doing, a ggplot or what, right? That's also in this server script where you would be specifying where to send or retrieve data from some type of API. And then the user interface is where you would do things like define a text box where a user could enter in their text, right? And then maybe create a global variable that would pass through that user interface to your server script to do some type of analysis. So the global part of the script is, again, the kind of the memory of the app. It stores things you want to call from other parts of the app, the user interface or the server. The server you can think of as kind of the brains of the app. It's where the analysis is going on. It runs the analysis you might want to show a user, but it can also store data generated by the user or expose users to different types of information if you wanted to embed an experiment within your app, for example. And the user interface you could think of as kind of the face of the app. It's what the user is going to see on the screen. Is there going to be a visualization? Is there going to be a text box? It could load fancy images or logos and improve the overall appeal of the app too if you wanted to make it attractive and visually appealing, right? So obviously we haven't really worked through all the details, but this is the architecture of a Shiny app. User interface, you've got some kind of widgets or text boxes that would allow you to collect, say, your survey data. Then you've got your server script, which is loading data, maybe making API calls if you want to build an app that merges survey data and API data. It's doing some type of analysis, and it's outputting something back into the user interface for the user to look at. OK, so you're probably thinking, if you've never worked with an app, because nobody raised their hand, that, OK, well, this sounds like a lot of work. And that is true. However, and this is where it gets really exciting, there's lots of people building lots of apps who all share their code online. So for example, let's say you wanted to build an app that integrates Twitter data with survey data, right? There are various websites. One I like is called Show Me Shiny here. And this is a website that will contain a ton of different Shiny apps. And each one, or at least most of them, will include the source code. And so if you come here, you can, here's a GitHub, I think with the, or no, there's a no longer working page. Anyways, I promise many of these, here's the code, will have the type of scripts we were just looking at. Here's the global script, the server script, the user interface, and we'll even sometimes in great detail show you the documentation. Why am I showing you this? Well, if it's the case where you want to build an app that collects Twitter data and survey data, for example, find an app that makes Twitter API calls, and it might be as simple as switching out some of the parameters to do the analysis you wanted to do or deliver to the user instead of the analysis that the app that you're hosting on. And this, by the way, this kind of, this is what, in this world, if you're not yet comfortable with the idea of using other people's code, this is how so much of our world works. We depend upon each other. And so, we all love the innovator who can produce the first code. That's critical and vital. But many of us, even at the most expert levels, are borrowing heavily from other people's code. Why? Because it's so hard to have all the skills to navigate, from, say, survey design to HTML to, say, experimental design, right? And this is another reason why team-based research, right, where maybe someone has better engineering skills, but someone has better experiment skills, and another person has better survey skills, and another person has qualitative knowledge or theoretical knowledge, right? These are the teams we need to put together to do the best research, I think. OK. So check that out. There's lots of great templates. You might find yourself able to build a Shiny app in 5 minutes. I mean, maybe not one that does everything I just showed you, but a simple Shiny app. Great for teaching, too, as an aside. And you could link to cloud servers through the Google Drive package or other packages available in the tidyverse. And again, app hosting is available from RStudio. OK, so in the 15 minutes we have left, I want to talk about a really exciting new field of research, which is using bots for social science research. Right? We think, and if we're reading media accounts lately, we've seen numerous examples of how bots have done terrible things in the world, right? Spreading misinformation, distributed attacks on websites, right? And yet at the same time, the study of bots, what they do and how it's really in its infancy. I think there's a lot of new research coming online on that, how bots spread information and how which type of people interact with bots and how and whether they know they're interacting with bots and all these type of interesting questions. But we can even go further than that, which is itself an interesting line of research, which is to actually build our own bots to deploy in, say, field experiments. So here's a nice example from last year. A very entrepreneurial PhD student in political science discovered that he could build a bot with a very cute title here, Tweetman Effects on the Tweeted, that would experimentally sanction people using racist language on Twitter. And so he built this bot. Here's one of the bots here, and here's another one. And so here's someone saying something racist, and the bot would search for people saying racist, probably using a call to the Twitter API like we looked at earlier, right, and get a database of people who had said some type of racial slur. And then he built 2 bots. Actually, I think ultimately there were 4 bots, but the important difference between the bots was that some of the bots had an avatar with a dark-skinned avatar, and some of them had an avatar with a light-skinned figure. And both of them said the exact same message, something sanctioning criticizing the person for using the racist language, right? And of course, dispatched this in an experimental manner, so I had a control group and a treatment group, and finds quite interestingly that people are the people who use the racial slurs are much less likely, or significantly less likely to sanctioned by the white avatar than by the dark-skinned avatar, the African-American avatar. And so showing that, the nice contribution around showing how the effect of those criticizing racism could potentially stem the spread of racism. The paper, I think, is not perfect. There's some issues of post-treatment bias or attrition in the sample, which is another example of how our data can be incomplete and imperfect. But I think it was just a really creative and nice idea to think about using bots for social science research. And so my group here, and some of our TAs here have been involved in this, has also been using bots, but for another purpose, which is to study social media and political polarization. And so in this study, we recruited a panel of about 1,600 Republicans and Democrats. And we administered a survey to them. And the survey asked a range of questions about their political beliefs, especially attitudes about the other party, but also substantive issues around, what do you think of climate change? What do you think of government regulation of the economy? Things like this. And we also asked them for their Twitter handle. And of course, we in our informed consent dialogue, carefully described how we were going to use the Twitter handle and what type of information was going to be collected from their Twitter account. And importantly, that we were also going to merge their Twitter data with their survey data, which, as you can imagine, is a really sensitive data point. OK, so we ran that survey. And then once we had their Twitter handle, we began scraping much of their Twitter information, their tweets, their networks. We used that, interestingly, to identify people who were, as far as we could tell, lying about their identity. So when we cross-referenced our Twitter location fields with the self-reported zip code of the people who had taken our survey, we discovered that 62 of the people who claimed to be, Republicans from Oklahoma who voted for Clinton or Trump were actually unemployed Venezuelan computer programmers who had used Tor to mask their IP address in order to deceive our survey firm to take the survey, right? 65, pretty big number, pretty good survey firm too, which was concerning. Also, we use that data to collect network data, right? So we can know if anyone in our sample is connected to each other on Twitter, which is going to be important for us because our treatment is going to be exposing them to out-partisan information. We discovered that about 190 people in our sample were either part of a large network component, a large cluster of people who are connected to each other from someone else, or were part of network dyads. And so when we thought about it, when we go to do our treatment with our bots, if we treat one person and not the other person, and that person starts retweeting the stuff our bot is retweeting, then we're treating the 2 people. And then when we go to subtract the difference between the 2, we've got a big problem with causal interference. And we were able to tackle this problem too by merging digital trace data with survey data. OK, so that's just everything before the treatment and before the bots. We then, 1 week later, in an ostensibly unrelated design where we stagger the invitation or the treatment, the subsequent survey, we built bots that randomly retweeted messages produced by a population of opinion leaders who were either Republican or Democrat using some network-driven sampling message developed by a fine scholar I mentioned earlier, Pablo Barbera. And essentially, we get elected officials. We scrape the names of the people those elected officials follow. We build a large graph of people who are followed by a lot of elected officials, which we use to infer the ideology of non-elected officials. Then we have a great big graph we do a correspondence analysis on that graph. We pull out a feature that is a left-right continuum. It's crude, but it's roughly follows party. And then our bot, which is hosted on a cloud server, is randomly drawing from those two populations and exposing our Democrats to Republicans if they're in the treatment condition, and then our Republicans to Democrats if they're in the treatment condition. So our bot is just randomly retweeting the bot. Then we use surveys to monitor whether people were paying attention as well. So our bots would once a day tweet a picture of a cute, adorable animal. And at the end of the week, we would delete all those tweets and then resurvey the respondents in order to determine whether they could identify the picture of the animal that our bot had been tweeting, so we could measure compliance with treatment. And then finally, at the end of the experiment, we are also re-administering the original survey in order to calculate a kind of difference in difference, a change in political attitudes over 1 month treatment period during 2017, October 2017. And so the thing that I think is neat and relevant to our conversation today is that we're combining digital trace data and survey data, and we're learning a lot, right? We were able to identify these problems with the data quality issues, causal interference issues, but we're also getting so much that we can't get from the Twitter data. Things like demographics, things like other variables like whether or not someone voted that turn out to be very important for our research question. And also we can embed a field experiment within this design using bots, right? And so just in case you're interested, we found that here's different levels of compliance. Here's Democrats, here's Republicans. If they move left, they're becoming more liberal. If they move right, they're becoming more conservative. And this is, again, the difference in difference estimate, so who changed in treatment compared to control. And we find that for Democrats, when they were exposed to the Republican bot, they didn't change terribly much, right? They became slightly more liberal, maybe. There's some issues with our, the estimate we have the most faith in is this one. These have some issues with the assumptions that I could talk about if anybody's interested. But look at the Republicans here. Moving almost 3/4 of a standard deviation, becoming more conservative in response to being exposed to our liberal bot. And this has provoked a series of follow-up studies now on asymmetric polarization and exposure to outpartisan information. And so without going into the study too much, I just wanted to, again, signal the value of hybrid approaches, which, as I mentioned earlier, the days of publishing a paper with just Twitter data that just, for example, build a nice network plot, right? Those are long gone for all the reasons that we discussed at the beginning of the morning, that all the weaknesses, the non-representativeness, the inaccessibility, the drift, the algorithmic confounding, right? And combining surveys with digital trace data and using bots to run field experiments or embed field experiments within this message gets at some of that, but there's still questions remaining, right? About, for example, algorithmic confounding. So one of the challenges for us was trying to figure out whether Twitter's timeline feature, which is now sorting like Facebook's, to promote things that people are more likely to like or interact with, was in fact shaping our results somehow. And we took a number of steps to try to do our best to get around that problem, but we couldn't know at the end of the day that there isn't something inside Twitter driving that result, right? And you could say that's still a finding about how Twitter works, right? And this is an important distinction. Our research question was about how this is unfolding on Twitter. We would be very hesitant to draw inferences about that would generalize our findings to the general population. So, okay, so in the few minutes we have remaining, how do I build a bot? So obviously, there are a range of ethical issues involved in bot construction. Twitter has a web page on its automation policy. I can't describe it in detail for you because it's very long, but the two key things that are expressly prevented are bots that spread information or bots that do some type of coordinated or distributed attack on either a given user or a website, and especially those bots that repeatedly like or retweet things, which have been shown to be central to these misinformation campaigns and networks of bots on Twitter. Okay, so all that said, you've done your careful research, you've gone through IRB review, And importantly, and this is again another theme from Matt's lecture on ethics yesterday, you've taken the extra step of talking to your colleagues and really thinking carefully, not just about what you would like, right, if you were exposed to bot, but if someone else was exposed, right, and thinking of the experiment and this is important for any number of reasons, including the increased scrutiny of our field and your obligation to future researchers. So here's an example. This is a very, very simple bot. This code assumes that we have authenticated with Twitter, right? And what this bot is going to do is every day it's going to search for tweets about computational social science, 50 of them, pick one at random, and tweet it, and then sleep for a day, and then repeat. Okay? So this is a very, this is a clunky bot. Maybe one of you will build this bot. That would be cool, I guess. I don't know. So you can imagine this could get much more complicated, right? In the case of the Munger paper I mentioned earlier, right? We might use search tweets to look for racial slurs and then do some type of careful review of those. I think in his case, he actually reviewed it by hand, but you can imagine doing it programmatically as well. Then you'd need some type of randomization, or you'd need some type of sampling frame if you are going to run a whole experiment, right? You could imagine embedding various forms of text analysis in here to extract features from the text that then could be related to the field experiment. The world is your oyster here, but you can imagine a lot of different stuff going into this code. Typically speaking, we would host something like this on a cloud server, something like Amazon EC2 or Google Cloud Computer. And we could, there are instructions about how to spin up one of those servers in the annotated code that is linked on the main web page. And here's an example of how you might make the bot interactive. This is from the Munger paper. This is his kind of decision tree that says exactly how his code was sampling tweets before he replied to the racist tweets. So obviously that could require a lot more coding and skill. And hosting a bot, again, something like Amazon Web Services, you would want to use that to both probably host the bot and maybe store data that is collected by bots' interaction with people. We've already discussed some of the ethical issues here. Again, let's keep this in our minds. And if you're interested in more detail about how to build apps, I'd be happy to share the code that we use to build our bot, which will soon be posted on the Open Science Framework, which I think Matt's going to talk about next week. You're talking about Open Science Framework. Yeah, so I think we are out. We have time for maybe one question, unfortunately, because we're right at 12:30. Yeah.
Well, we have one question.
Oh, great.
Austin from Cooney Hunter wanted to know, is API extraction here to stay, or do you think that it is only a matter of time before it becomes outlawed, banned, like screen scraping?
It's a good question. I can't see the future. I would say I don't think it's going away because, again, it's become a very convenient way of ensuring safe, secure access to those who are allowed to access data. Whether we might see more efficient technology to do that, I'm almost certain that we will. But I think the principle of researchers needing to form a contract with an organization that maintains an API is something that we will see for a long time to come, because we have to find some kind of sweet spot in between, everybody gets access to all data and, only people inside a industry group get access to that data, right? And that, like, the internet wouldn't work if we went to that extreme, right? So I think we will continue to work to find that sweet spot. I can't say exactly what it will be, but I think something like an API is here to stay.